Welcome to this video. My name is Chisola Nyala. Today we'll be looking at differentiation of products or functions. Differentiation of product of functions. Now, the first important aspect that you really need to take note under this type of differentiation is being able to identify whether the problem given to you is under this category. So we can also call this kind of differentiation as the product rule. This is how most of the authors would like to actually name this topic. So we will be looking at the product rule. So the most important aspect is being able to identify whether the question is under the product, whether the question can be approached using the product rule or not. Now, if you remember, if you recall from our previous videos, we had something like y, which was a function of x. For example, y could have been e raised to the power of x, y could have been x raised to some nth power, maybe power 6. Now, this is a function. It's a single function, but how can we tell when we are dealing with a product of two functions? So instead of actually having the function of this form, we'll have a function of this form. Y will be a product of some function multiplied by another function. Both of them are functions of x. So immediately these two conditions are satisfied, then we have to do the product rule. So let's say let y is equals to u multiplied by v. Now, it's important to note that both u and v are functions, and they are both functions of x, and then it implies we can use the product rule, which I want to actually now define and explain. So this is the product rule. It's always in this form. Y is a product of two functions. In this case, we have in u and v, where both u and v are functions of x. Now, what is the product rule? If you want to differentiate the this type of functions, we're going to say dy dx is equals to u multiplied by differentiating v with respect to x plus, now this time making v a constant, multiplied by differentiating u with respect to x. So this is the formula. This is called the product rule. It's simple as this. So you differentiate, you keep the first function constant, you differentiate the second function, you then add by keeping the second function constant and differentiating the first function. Now let's do a number of examples to get hang of this topic. So let's get started. So example 1. Let's say you have y is equals to e raised to the power x multiplied by sine x. Now you understand that both sine x and the exponential are both functions. So we have the exponential function and sine. and the sine function. So definitely this is a product rule approach. So what is our u? U is e raised to the power x. And what is our v? Our v is sine x. And what is our formula? Our formula states that dy dx is equals to, I keep the first function constant u, which multiplied by differentiating the second function v dv with respect to x, because they are both functions of x. Then I add by keeping the second function constant as the way it is, and then differentiating the first function with respect to x. So what is the solution to this problem? So this is our formula. So what is the solution to this problem? What is v? Our v is e. So dy dx is equals to, keeping the first function constant, e into x, multiplied by differentiating the second function, which is sine x. When we differentiate sine x from the standard table that I gave you from in the previous video, we'll get cos x, plus keeping the second function constant, which is sine x, multiplied by differentiating the first function, which is e power x. Now we can write this solution in a compact form by saying dy dx is equals to, we can factor out e raised to the power x, then we'll have cos x plus sine x, and this is our solution. Let's do one more example, and then I'll summarize this video. Then I'll do 2 more examples in the next video. So example number 2, we have y is equals to 4x raised to the power 3 sine x. What's the formula? dy dx is equals to u dv dx plus v du dx. What is u? U is 4 x cubed, so dy dx is equals to 4x power 3 multiplied by dv du. So when we differentiate the second function, which is sine x, we'll have cos x, plus keeping the second function constant, which is sine x. When we differentiate the first function, which is 4x cubed, so we'll have 12x raised to power 2. We can write this in a compact form by factoring out 4 power 2. We'll have x cos x plus 3 sine x, and this is the solution to this problem. I hope this video made a difference and you got something. Catch you in the next video where I'll do another example to just cement the topic. Thanks.